The English chemist named Robert Boyle is widely known for discovering the theory that states that the volume of a given mass of gas varies inversely with the pressure when the temperature is kept constant. This describes an inverse relationship, as one variable increases in value, the other variable decreases. The formula for Boyle's law is P1 times V1 is equal to P2 times V2, where P is for pressure and V is for volume. Boyle's law is important when using a syringe. When fully depressed, the syringe is at a neutral state with no air in the cylinder. When the plunger is pulled back, you are increasing the volume in the container and thus reducing the pressure, while the other increases. The liquid draws up into the syringe because it balances the pressure, making it equal to the pressure outside of the syringe. For example, a balloon contains 8.3 liters of helium. The pressure is reduced to 2.5 atmosphere and the balloon expands to occupy a volume of 27 liters. What was the initial pressure exerted on the balloon? Our initial volume is 8.3 liters, our final volume is 27 liters, and our final pressure is 2.5 atmosphere. Our initial pressure is not given, so let's go back to the formula for Boyle's law, which is P1V1 is equal to P2V2, where P1V1 is our initial pressure and volume, and P2V2 is our final pressure and volume. Since we're looking for the P1, which is the value of our initial pressure, we divide both sides by P1, so we're going to arrive at the formula of P1 is equal to P2V2 over V1. Let's substitute. So we're going to have 2.5 atmosphere times 27 liters all over 8.3 liters. The unit liters will be cancelled out, and the only remaining unit is atmosphere, which is the unit that we use for pressure. Your answer should be 8.13 atmosphere, and that's the value of our initial pressure. The French physicist Jacques Charles studied the effect of temperature on the volume of a gas at constant pressure. His law states that the volume of a given mass of gas varies directly with the absolute temperature of the gas when pressure is kept constant. The formula for Charles' law is V1 over T1 is equal to V2 over T2, where V is for volume and T is for pressure. If a gas is heated, it expands, and when it expands, the gas becomes less dense and the balloon is lifted in the air. The warm is less dense than the cold air, which means that it is lighter than the cold air. Okay, so for example, a sample of oxygen occupies a volume of 150 ml at 75 degrees Celsius. What will be the volume of oxygen when the temperature drops to 0 degrees Celsius? Our initial volume is 150 ml, our final volume is not given, our initial temperature is 75 degrees Celsius, which will become 348.15 Kelvin, and our final temperature is 0 degrees Celsius, which will also be converted to Kelvin and will become 273.15 Kelvin. The formula for Charles' law is initial volume over initial temperature is equal to the final volume over final temperature. We will manipulate our formula and isolate our final volume by cross-multiplying and dividing both sides by T1 to be able to get the formula for our final volume, which is V1 times T2 over T1. We're just going to substitute the given to our formula, so we'll have 150 ml for our initial volume times our final temperature, which is 273.15 Kelvin, all over our initial temperature, which is 348.15 Kelvin. So the final answer should be 117.69 ml. Joseph Gay-Lussac is a French chemist that discovered the relationship between the pressure of a gas and its absolute pressure. He is also the proponent for the Gay-Lussac's law. This law states that the pressure of the given mass varies directly with the absolute temperature of the gas when the volume is kept constant. The formula for the Gay-Lussac's law is P1 over T1 is equal to P2. For example, if a gas in a closed container is pressurized from 17 atmosphere to 19 atmosphere and the original temperature was 35 degrees Celsius, what would be the final temperature? First, to identify the given. Our initial pressure is 17 atmosphere, our final pressure is 19 atmosphere, our initial temperature is 35 degrees Celsius, which we'll need to convert to Kelvin. We'll arrive at the formula for our final temperature, which is equal to the final pressure times the initial temperature all over the initial pressure. Unit left is Kelvin, so our answer for our final temperature should be 344.40 Kelvin.
Amadeo Avogadro was an Italian physicist and lawyer. He is well known for Avogadro's law, or also known as volume amount of gas relationship, that states that volume increases as the number of particles increases if temperature and pressure stay constant. Also, volume decreases as the number of particles decreases if temperature and pressure stay constant. The formula for this law is V sub 1 over mole sub 1 is equal to V sub 2 over mole sub 2. Now, for an example of Avogadro's law. If 0.75 mole of gas has a volume of 4 liters at STP, or standard temperature and pressure, what would be the volume of a 0.50 moles of gas? So, the given are the following. Since V sub 1 is 4 liters and N sub 2 is 0.50 moles, we will multiply them and divide them by N sub 1 or 0.75 moles. Moles will be cancelled, thus giving us a final answer of 2.67 liters. Next is the ideal gas law. The ideal gas law is a single equation which relates the pressure, volume, temperature, and number of moles of an ideal gas. Ideal gas law demonstrates a relationship between the given variables for a combination of ideal gases, from which simpler gas law such as Boyle's, Charles, Avogadro's, and Amonton's law. The formula for ideal gas law is pressure times volume is equal to number of moles times R times temperature, where R is a constant 0.0821 liters atmosphere over moles Kelvin. Now, an example of ideal gas law. At what temperature will a 0.548 moles of neon gas will occupy with 10.5 liters at 2.3 atm per atmosphere? Let us analyze the problem. So, substitute the given into the formula. 2.3 atm times 10.5 liters over 0.584 moles times 0.0821 liters atmosphere over moles Kelvin. Simplify the equation and we will get the answer, 536.78 Kelvin.